Praveen, congratulations.
Thank you very much. Appreciate it.
Please. And let's hold this.
Oh, you capitalized on this.
For our winners, one last round of applause. So you saw 40 companies today. I know you might have trouble remembering exactly which companies these were, so we're going to give them an additional 10 minutes to pitch. So that's going to be 10 minutes of pitching plus Q&A, so get your questions ready. We're going to go alphabetically, so we'll start off with Praveen from Inflexol. Congratulations, Praveen.
Thank you. So, first of all, let me thank everyone who voted. We really appreciate it. It's been a long road. You know, we've been in stealth mode for 7 years, and today's the first day we can actually talk publicly about what we've been doing. And it's actually been a very big day, besides being here at Plug and Play and having all of your support. Our co-founders are actually in Anaheim right now, presenting the technical aspects of our solution at a conference there. And we just won a large contract with the Oak Ridge National Lab based on our presentation today. So it's been a good day for our small company. Thank you very much. So just to review, you know, it's been a few hours now, so I'll go over the high level first again in case you missed it. But we're in Inflexol. We are an advanced green manufacturer. Our mission is to revamp the way electronics and photoelectronics are made. Like, most people don't realize this, but you know, everyone assumes like the oil industry is the dirtiest industry, but electronics are actually not clean at all. I mean, semiconductors, there's a witch's brew of toxic materials that goes into making a chip, and anything that has to do with chip technology like LEDs, same thing. You know, there's everyone knows about conflict diamonds or blood diamonds, right? But there's also conflict minerals. A lot of the minerals that power our advanced society are actually mined in very underdeveloped countries, and there's wars going on for these minerals. So what we do at Inflexol is we're trying to save the world in our own way by making manufacturing greener. So we invented a new science called the science of laser alchemy. And we have a new tool called the Alchemist 1.0 laser machine tool. If it was sitting beside me, it'd basically be a very large machine, so it's not something I'm going to bring with me, but I'll show you pictures and videos of it. So our first real-world application, which some of you saw the videos when you came to visit our booth, is the LightGen brand light-emitting glass. So it's the first time ever you can take a piece of glass, in fact our demos are just glass we buy from Home Depot, and turn it into an electronic device without any sort of metal. So basically it's a light bulb with no discrete components, and we have 11 patents on this and 12 pending. And basically, you know, we're a science company. In fact, one of our founders actually worked with the original inventors of the microchip, including Shockey. They're actually much older than me. Of course, they worked with them in the 60s. But you know, we're a pretty cool young company. You know, you have to get to know us, and we're very friendly. So, and it was actually very educational walking around out there. You know, there's a lot of good investor questions we have to answer. You know, so hopefully with the community out here, we'll be on our way. So let me get started with the presentation. So this is our glass. It's an ordinary piece of glass, and we turn it into light emitting. And each of those dots is actually twice as bright as a conventional LED light bulb. And we do this at 1/10 of the cost. So I was talking to the Samsung guys out there. One application would be to take the entire front glass plate of a phone, I guess a Samsung phone for them, not an iPhone, and turn it into a powerful flashlight, which uses only half the electricity of an LED, but costs 1/10 of the price. So the way we do this is we actually use laser doping, and we actually create something called tunable PN junctions inside the glass itself. And that's Nat Quick. He's our chief scientist and the founder as well, and he's the one that worked with Shockey. And all of our patents are under his name. He's actually our genius, so to speak, and that's our Alchemist 1.0 laser machine tool. So the really cool thing about what we do is, you know, we're creating these electronic devices without any toxic materials, no metal, no water, and we use very low electricity even though we're using lasers. So it's a really amazing process, and I'll show you all the market validation in a few slides. So we have a robust product roadmap. The glass that I was demoing outside is actually for our 1.0 model. That's what we make with our Laser Alchemist 1.0 machine. The 2.0 machine is when we're going to actually create solar-powered glass. Basically, instead of light-emitting glass, it's basically glass that absorbs light as a solar panel would. That's what we call the direct energy conversion material. And then some other cool concepts like the magic lamp, basically unplugged indoor lighting, some cool product ideas. And then long-term, the Alchemist 3.0, it's more like back to the future. Most people don't realize this, but the current way microchips are designed with PN junctions isn't really the original intent. Originally MIT intended for what we trademarked the name, the material is the computer, actually putting direct writing circuits onto material, not having like all this like photolithography or anything. So we went back 50 years, took an idea MIT originally thought of, and we actually developed it and patented it and trying to create products on a new way to make electronic devices. So we have 11 issued patents, 12 applied for. We own the entire IP stack. We don't reference anyone else's patents. We've already generated $1 million in revenue from Intel, the Department of Energy. We have memorandums of understanding and interest from General Electric, grants from NASA, NSF, and just now we have a contract with Oak Ridge National Lab. So our first industry we're targeting is the lighting industry. Right now it's a $75 billion industry, and our total available market is 22.5. That's what the light bulb is. The other parts of the lighting industry is kind of like fixtures. So within the 22.5, we're targeting the LED industry, which should grow to 50 billion just by itself by 2015, according to Philips. So as far as like why we're better, I mean, this is, if we added another column here to show LEDs, we'd be even more off the screen, even more disruptive. We're basically cost 1/10 the cost of our current competitors, and we last 9 times as long, and we're much brighter. So basically, this is our, us on the left and the LEDs on the right. We're basically a clean, simple, 2-step process for producing a new type of light bulb, and LEDs are basically a 50-step process. And this is our LED competitor, the Franken bulb, as we like to call it, the latest GE light bulb. It's overpriced at $50, low light. There's no energy savings over compact fluorescent lights, and I fail to see who, other than early adopters, are going to buy a $50 light bulb, basically. But that's what people are investing billions of dollars right now in fabs to build this thing. So, basically, we're a material, not a device. So a lot of things, we don't have filaments. Basically, that glass you see, that's it, basically. There's nothing inside that glass. We're cheaper, better, disruptive. And what we're trying to do right now is build our first pilot plant. So we want to build a light bulb factory, so to speak. And the pilot plant, we are predicting $250 million in revenue in year 5 for one plant. And we're going to build multiple plants concurrently as we prove the technology. So right now we need $1 million to further our R&D and actually create the actual light bulb form. If you saw the demos outside, all of our glass is flat right now, so we have to like curve it. So it's basically some mechanical engineering involved. All the science and all the machinery is already proven, and we've already have patents and a lot of market validation on that. We need $10 million to build our plant, and then we'd also like to do additional grants and consulting contracts while we're in the Valley. So any questions? Yeah. Yeah, so yeah, that's a common question. Everyone outside was asking, obviously, the same thing. So we've been out of stealth mode. Oh, so he was asking about links to technical papers? Yeah. Yeah, so all of our patents are obviously public information. So you can do a patent search. You just search for Dr. Nathaniel Quick. But you can just go to the website. We'll update the website. We're only out of stealth mode for 2 hours now, so you have to give us some time to get that information out. Anyone else? Go ahead.
Yes, hi. Can you comment on scalability for your scale-out manufacturing? What are the challenges that remain?
Sure. So that's a very good question. At the booth, we actually have our architectural diagrams of our proposed plant. You know, we basically we're a very lean startup. You know, we don't have any investors right now. We've self-funded this, and we've had contracts and grants. So, along the same lean philosophy, we decided our first manufacturing facility is actually going to be, you know, inside of an existing facility. So we're going to sublet space, and our Laser Alchemy 1.0 machine is basically, you know, a machine tool, so to speak. So it's basically be one worker operating the entire machine, and one worker can make, you know, XX number of products per hour, and that XX number will be, you know, increase as we work out the bugs in our production process. So it's basically a machine shop at that point. And then, you know, as we become more sophisticated after our first pilot plant, we'll come up with new production techniques, maybe an assembly line.
If we have no
Okay.
more questions, we have time for one more.
Consumer question, not an investor question. Given you will all be interested in using your products, when is it going to be actually out in the field?
Okay, so he has a very interesting question. He's asking when you can buy this, basically. So we are less than a year away from commercially releasing our first product, which is going to be, you know, a light bulb. So, you know, the hard part's already done. We've been working on this for 7 years now. You know, basically creating a new field of science and issuing all these patents and doing this when we're underfunded, basically. You know, if maybe, you know, thank God for unanswered prayers. Maybe if we had a lot of money, we would have gone down a different path. We wouldn't have come to where we are now. But basically, we feel we're a year away, and then that's also dependent on actually, like, you know, building our first plant as well. But we had some interesting conversations, and if anyone would like to help, you know, we could possibly, instead of build our own plant, we could contract manufacture this with someone else. But that's something we can talk about. You know, we've only really been considering this for a few hours now. But thanks.
Great. Thank you very much, Praveen.
Congratulations.